Today we're jumping into what is a virtual private cloud in Amazon. Virtual private cloud is basically an isolated section of the internet, which is your own little space that you can control and you can decide what goes in and out and how it interacts with the rest of the internet, not all the other information that's going on out there. Some terminology before we start. If you imagine that your VPC or virtual private cloud is like a little city that you can run and own, then subnets are like the neighborhoods of that city. If you have a public subnet, then it's like having a publicly accessible area in your city. Maybe this is like a mall or a supermarket. And then if you have a private subnet, then this is something that not everyone in your city can get access to. Maybe it's a gated community, like a retirement village where you need a code to get in. Maybe it's some top secret facility that not everyone can access. That would be a private subnet versus a public subnet, but they're both within your network. Also on here is IP addresses, so we need to understand what is an IP address. An IP address is like a physical address for your home, like 123 Awesome Street, except that it's for your laptop or your computer. Instead of having a street name and a number, for example, an IP address is just a long string of digits that kind of makes up a unique code or a unique address for all the different devices that are on your network. So how does this all connect with AWS? That's where we use gateways. Gateways is how we can allow people to come in and out of these public or private areas of a network. For example, if you have a private area, you need to have a gateway that is controlling who is going in and out so that you make sure the people going in are only the people that you want to go in. If it's a public area of your network, then we call these internet gateways. If it's a private area of your network, then we call these virtual private gateways. And if you want a super fast, super direct way into a subnet or into a part of a network, then you could use AWS Direct Connect, which is basically like tunneling under the city and getting a direct train that's going to go exactly where you want it to go. Now, if you are using the private gateway, then it's also going to create for you what's called a VPN, which means a virtual private network. And a VPN is basically like traveling with a security guard because it means that it's protecting the traffic that's going from one place to another. No one else is going to be able to interrupt or corrupt or stop or influence that data as it's going from one network to another, because they're using a VPN, which creates a very secure pathway from one network to another network. Then once you get to wherever you're going, then your virtual private gateway is actually going to just do a double check and say, excuse me, are you what we thought you were? Do you meet these requirements? And if it does, then it will let them in. And if it doesn't, then it says, sorry, you don't meet this requirement, so you're just going to have to turn down your fancy VPN and go back the other way. You're out. So if we put it all together, then one virtual private network or one VPC, one virtual private cloud, can have multiple different gateways, a whole bunch of different virtual private connections or VPNs, or it can use AWS Direct Connect to get data across super speedy, super fast. Now let's zoom in into one area in particular, an important one, which is security in a virtual private cloud. Now, if we go back to our city example, we have a couple of new terms to introduce. One of which is a network access controller, which controls all of the traffic which is entering or leaving a neighborhood or a subnet. You also might set up some security groups, which in our city example is like if an EC2 instance is one particular building, then a security group is protecting just that one building. So they are like security guards on that one building, a security group for your EC2 instances. Each building can have its own set of security groups or its own security guards that decide who goes in and who goes out. So how it works is that a customer, some user on the internet, might request some data from your application. And so that request gets sent over as a packet. A packet is basically a little unit of data. You can think of it as like an envelope or something that comes over the internet and it's going to AWS and it's saying, no, we've just had a request. Someone wants to access your application. The request packet is going to enter into your virtual private cloud through an internet gateway because it's coming from the big outdoors, the internet. But then before it can enter any of the subnets within your virtual private cloud, the network access control list needs to check the packet's permissions. The permissions include who actually sent this packet, what do they want, and is it going to be approved? Once that packet has passed the access control list and it's now in your subnet, then it will hit the security groups that are around your specific EC2 instance and actually make sure, all right, final checks. Are you actually who you say you are? Are you malicious? Are you going to hurt our EC2 instance or the wider network? And if it all looks good, then it will get in, get the data that it needs, and then head out in the reverse direction. So what's the real difference between access lists and security groups? Great question. Network access control lists operate at the network layer. This means that they are basically checking a packet's data for the source and destination IP address, where are you coming from, where are you going, any port ranges or protocols, things like that. This is different from a security group, which is operating at more of an instance layer. So they are determining who can enter and exit a specific server, whereas the access control list is for the entire network. Access control lists are also stateless, which means that they are checking both packets that are coming in and packets that are going out, whereas our security groups are stateful. And what that means is that if they let you in, then they remember that state. They remember, oh, we let you in. So then when you come to go back out, they go, oh, don't worry about it. We remember you. You were all good. You came in. So no problem. Out you go again. So stateful is where they're remembering a previous state, and stateless is where they say, hold on a second, I've never seen you before. Even if they just saw that person come in, now they're seeing that go out, and they have to check them again to make sure. Coverage-wise, access lists apply to everything that's going into a particular virtual private cloud, whereas our security groups are just for that one instance. Access lists have an explicit deny by default rule. This means that they've basically got a list of criteria which says let it in if it meets all these criteria, and if it doesn't meet that criteria, then just deny it straight away. So default deny unless you meet this criteria, and then you can come in. This is different to a security group, which by default is going to check all incoming traffic, but then allow all outgoing traffic. You can change this, you can update it, but it is different to what we see in our access control list. Now let's talk about ports and protocols. Where do they come in? Protocols are basically a set of rules for how data should be sent and received. You might know a few of them. For example, we have HTTPS or HTTP. HTTP stands for Hypertext Transfer Protocol, and it's a standard protocol for transmitting web pages over the internet. You might notice that your web pages start with HTTP. Now, if it's got that S on it, so HTTPS, that just means that it's got another layer, another step to that protocol. This extra step is for security reasons. So you'll often find that sites that need to be very secure, like banks or internet banking, for example, they'll always have HTTPS because they need to have that extra step in the protocol to make sure that everything is secure and works out. SSH is another one, but where HTTP is used for web pages, SSH is used for more managing and setting up things in a network. It's not a tool that we'd use every day, but if you're in the world of networking, you're setting up ports and protocols and networks like what we've been talking about, then you'll probably be using SSH quite a lot. Ports are another important term to know. I like to think of ports like the gates at an airport, where you need to get on that plane to go somewhere, but you've got to make sure that you go to the right port. Otherwise, you're going to get on the wrong plane, or you're going to miss your flight, or something bad's going to happen. A port is like making sure that you go to the right place. Different ports have different protocols. For example, port 80 is commonly used for HTTP, and then port 443 is used for HTTPS, and then port 22 is often used for SSH. These are just a few examples, but ports will turn up all sorts of different places because it's about going to the right place to actually get into a network or where you want to end up. Thank you so much for watching. Happy learning. We'll see you in the next video.